Hello, everyone. This is the one of a few workbook tutorials for the Test 3 workbook. Let's jump right in. Here's problem 55, the standard probability distribution kind of setup. And here's what we would do with that. So I see that I have some payouts, if you will, and some associated probabilities. And boom. So you see that I've input them in here, hitting enter every time, and it's popped up. It's calculated my expected value, otherwise known as my mean. There's my standard deviation, variance. It's all right here. They're even using an alternate formula for variance that can be computed with the expected values. Okay. So that's that, right? We're done. Find the mean and standard deviation of the scores. Mean, standard deviation. Okay, now let's think about this. If we select a random sample of students, would you expect their scores to follow a normal model? Well, let's look at our probability distribution. You're not likely to get a 5. You're more likely to get a 1 than a 5, right? In fact, let me, instead of trying to talk around this, let's just make a bar chart real quick. I can even make a histogram. I should even be able to change bin width. Yeah, so 9%. Let's make the bin width like about a standard deviation. 2. I mean, point. Let's try that. Okay, that was a little too much. I'm going to use number of bins instead of bin width because I'm sick of figuring it out. Let's try 5. Where's 5? Yeah, and so this is that thing I talk about. When you're making a histogram and you're trying to figure out what the distribution looks like, why not make a couple? So that's what it looks like with 5 bins. We saw what it looked like with 7 bins. Let's see what it looks like with 12. Generally have between 5 and 12. Okay. So no histogram that I looked at was normal, right? It's all kind of right or left skewed, excuse me. So here's what I'm going to say about that. I wouldn't expect. The model, the population itself, right, is not normally distributed. So you don't expect values you draw from the population to be normally distributed. If I was then to average the scores of this 40 student sample, I would then, of course, expect those averages, those means, to be normally distributed. And yeah, that's about the shape of it. Now let's think about the second question here. Consider the mean scores. Oh, well, geez, I just answered that for you, right? Consider the mean scores of random samples of 40 AP statistics students. Describe the sampling model for these means. Well, it would be unimodal, symmetric, centered around the population mean. Yeah. Otherwise known as talking around normally distributed. So, so actually, I can jump over here. or not here, normal X bar, right? What am I thinking about? The means. I could answer question C by plugging in this, right? My mean, zoom out here. So from the problem sheet, I got a mean of 2.798. 2.798. From the Probsheet, I have a standard deviation. I'm just going to copy paste. And so I'm in the X bar here, right? And I'm going to put the population standard deviation right there. And these values, yeah. And my population was size 40. Yeah. So I would expect my normal model for a sample size of, or for my means for a sample size of 40. So the mean of 40 students repeatedly sampled, I would expect that to have a standard deviation of 0.211. A mean of the population mean, just like always. That's the size and shape of it. So you notice I didn't have to type a formula in here. I just had to put the population standard deviation here. So we'll see normal X bar again, but I couldn't resist the opportunity to check it out there. Anyway, I'm going to cut that off right there. I hope that's answered some questions about how to fill in the prob sheet and how to interpret the results. Yeah, I had them filled in when we started the video, but I mean, it is just typing, you know, that's all we got to do there. So anyway, I hope that was helpful. I'll be posting another one of these today where we talk about p-hat, and possibly a third where we talk about anynormal and normal X bar. All right, hope you all have a good day. See you noon or 1.